And welcome back to the morning show. It's coming up on 6:50. It's Wednesday. That means time for our Chemist Corner. Our resident chemist, Jesse Miller, is back from the U of I. Thanks for being here this morning. Talking about hydrogen, helium, universe formation, all that good stuff.
That's right. Okay, so I'm sorry about my voice. I came back from New Orleans with a cold.
Oh, okay.
Yeah, it's really great. So,
that's always a good sign of a trip.
That's
anyway,
right.
that's for a commercial.
Maybe too much screaming.
Let's do some chemistry.
Okay, so we're going to talk a little bit about the formation of the universe. As I said, depending upon what your particular theory is, whether it's intelligent design but we're going to talk about Big Bang.
Okay.
Okay, and so the universe started off with a bang. We have our supreme being here, which you happen to notice in my universe is a woman. Yeah. So we're going to have our little Big Bang here. This is really loud.
So Gretchen's going to help us out here.
That's right. This is Gretchen Adams.
All right.
Red balloon.
All right. We're going to go the red balloon. So you may want to zoom out. So this is going to be loud. So anybody in the studio, just be ready. Go ahead, Gretchen.
Go ahead. Okay. So.
That was loud.
And we cleaned your ceiling.
Thanks. Right. It needed it, if you haven't noticed.
All right, so we had our bang, and now in the beginning of the universe, the matter was about the size of, like an apple or your fist, right? Okay. All the matter in the universe was, was about the size of your fist, and it expanded real rapidly in this Big Bang.
Okay.
And as it cooled, it eventually formed hydrogen gas.
Okay.
So the whole universe was pretty much hydrogen gas. Okay, and then eddies, because it's chaotic, eddies formed and things like that, and eventually it particles pulled together with gravity. The gravity got bigger, masses got bigger, and finally you would start a sun. Okay. As these balls of hydrogen swirled around each other and got bigger and bigger, it would start compressing in on each other. Eventually, the hydrogen would start fusing.
Okay.
Okay, the heat would get great enough and the pressure would get great enough and it would fuse together, and it fuses from hydrogen, this is hydrogen gas, into helium. Okay, and that's what's happening with our sun right now. Okay, we have a lot of hydrogen still left. Most of the universe is still hydrogen. The second is probably helium. So the hydrogen is forming, and it's fusing, and this is hydrogen. We'll go ahead and let off. This is just regular hydrogen. The other one is hydrogen too, but we added oxygen to it.
Oh, okay.
This is just hydrogen. This is like the Hindenburg.
Okay.
Okay. Now this isn't what's going on with the sun because it's fusion, but it's kind of fun anyway. This is our sun.
Okay. Is this going to be loud too?
No, it's not going to be loud.
All right.
Yeah. See.
Wow.
All right. So. That's hydrogen.
We got a freeze frame of that. Look at there.
That's fantastic. That's great. So, all right, so we were fusing into helium. Eventually, all the hydrogen will be consumed. Okay. Okay, and then it becomes like a red giant. Okay, and then it'll collapse in on itself, and the next thing that's formed is the helium will start fusing together, and the next thing that formed is actually carbon. Okay, it's not lithium or boron. Those are from radioactive decay of some other elements. But there's a carbon, nitrogen, oxygen cycle that takes place. And so the next one is carbon. Now, we don't have a lot of carbon. We don't have a lot of helium or hydrogen on the Earth because the gravity of the Earth was not great enough to hold that into place. Okay. Most of the helium on Earth, as a matter of fact, is here because of radioactive decay of other materials, most of the helium. The hydrogen was caught up in water. Okay, so we do have some hydrogen, obviously. All right, so I have some liquid methane here. Okay. Actually, I think there's probably some. Okay.
I guess I should scoot back.
No, we'll have to wait here. We got some hydrogen or nitrogen.
You're a good shot, though. Two in a row.
Just hang on for a second. There we go. We should have enough methane in there to light on fire. No, yet. This is going to drive me bananas.
Well, it took a while.
See, what happened was
I
had some liquid nitrogen form on top of the methane. Try it again.
I think it's burning out before it gets there. But she's made every one of them.
Yes, she has. Go ahead. Keep this far enough apart.
Let's do 70.
Oh, you going to give it a shot?
Sure. It's just going to pop.
I can smell it. Yeah, there we go.
Striking out.
We just can't seem to get it going.
That's
I think I got too much liquid nitrogen that formed on top of this because I had to make it at the university. There, I bet. Okay, all right, fine. We'll just give up on that one.
So in chemistry this morning, we learned if you put fire into a liquid, it goes out.
Well, at least liquid nitrogen. Darn it. All right, so anyway, carbon was the next thing that formed. We don't have a lot of carbon on Earth, but eventually other things were formed called nucleosynthesis. It went through, and eventually it exploded in a supernova, and then will form again another nebula. And that's what our sun is, the second generation, at least second generation sun, which is why we have an Earth.
All right.
Okay. Hang on, let me get rid of this.
Okay, just about out of time.
I know.
So.
That's pretty cool, huh?
Yep.
All right, so the last thing we wanted to do, this is kind of a tease for the next one.
Just tell me, get out of the way. I
Trust me,
believe
this one will work.
You're wearing goggles.
All right. This is some calcium carbide.
Okay.
Okay, it's going to form acetylene gas. And when we come back for the next, I'll show you something pretty neat. But right now, this is just going to form some acetylene gas. And go ahead. Go to, well, this fire this morning is just not our friend. It's all right. Go ahead.
There you go.
All right, so when we come back, I'm going to show you some fire that takes place without air.
Okay.
Okay?
All right.
It'll work better.
Very good. All right, you can see a replay of this on our website, onlyhomepage.net. Look under the morning show, look under Chemist Corner. Jennifer, we